So welcome to the Node.js Node API team meeting for August 26, 2022. We'll follow our standard approach by looking at the issues that we've tagged for milestone 11. To the Node. Okay, let me share. Sorry, just get into the right repository. Oh, come on. Okay, can you all see that there?
Yeah.
Okay, good. Stop. Okay, come on. Okay, so the first one is drive towards full coverage. I guess, Jack, do you have anything we should discuss on that one?
Yep. So I've updated the PR to I think implement your suggestion where we unref it and then ref it and make sure that it hangs, and I think it's ready for a review.
Okay, so that's this pull request.
It's a node add-on API repo.
Right, yes. Right, node add-on. Node add-on. This one, right?
Yep.
Okay, so yeah, I guess we can have people can have time to go and do a review. That would be great. Okay, back to things here. I guess then just let's actually cover some of these first. Move these back up again. Move that. I think the better coverage node API on YouTube. I know that Nick was going to work on that, but he's away. Same with this next one on adding a list of non-C language bindings. So I don't think there's anything to talk about on those two, unless somebody has something specific. Okay, then oops. In terms of the tracking issue, let's see if there's anything new. So I guess I think that one was there already, right? Because that was 8 days ago. So it's just interesting to see a number of other runtimes implementing Node API. It's very interesting, but nothing new since last time. I haven't enabled debug testing. Okay. My changes aren't sticky, but anyway, okay. So I think that takes us to looking down at issues in the repos. So any particular ones in Node add-on API that people want to bring up that we should discuss? I don't think I see any new ones there that we should. And actually, I guess I missed the stale ones, right? Where are stale issues? Sorry. Okay, I'll go back to there. Right, this one I discussed. I think we discussed last time. I don't think there's anything new. This one, I think we wanted to wait till Kevin was back. And this one, I know Vladimir looking at anything to.
Yeah, I just submitted PR a few minutes ago. So just yeah, so CI right now is breaking. Like I need to look on fixing that. It works on Microsoft Visual Studio, but it seems like a client and some other compilers has issues, and it's what I see. Like Node version 12 has still running Node 12. Yeah, technically, this new example, which shows that how we can use JavaScript proxy to simulate some of V8 behavior. So technically, at this point, this PR has this example has folders for none and API.
Okay.
So none is pretty much I just picked up from examples from Node API examples effectively from one of the tests, and then I effectively side by side how can we do with plain NAPI. I still
Okay.
need to add our C++ Node API example on top of it.
Okay.
Yeah, at least it's kind of initial change.
Okay, so that sounds good. So you're making progress on that one. Which is good. Anything you want to talk about specifically on that, or just good?
No,
No.
just to be aware.
Yep, perfect. Great. Okay, that's good. So that takes us through those. Okay, I'm going to flip back to any issues. There doesn't seem to be any new issues like flags or anything. Is there anything? So I guess anything on ABI stable node before I flip over to core? No, I will flip over. And I'm going to then issues. Okay, so this is one newer one. I see Chenzong, you've already replied to that one.
Sorry, my internet is kind of slow today. I'm not sure why. Yeah, I just take a look at this one, and I'm sure this. I'm not sure how this person is producing the memory leak, but I would believe it would be very helpful if they can provide an example to the problem so that we can verify if the problem
Right.
exists here.
Right,
Since
if
we
anything, we'd
already
wanna
have
test.
since we already have an refactoring specifically on this side in the PR we can discuss later. The PR we are going
Yep.
to optimize the workplace. So I believe it will be helpful to have an example reproduction of the memory leak, the problem here.
Ideally, even we might try and put it into one of our tests or something.
Yeah.
Okay. Okay, that's good. Any others that people want to call out that we should go and look at or talk about?
If there, I can talk about. I can go through the PR of the finalize the second Pascal back. If there is no other topics.
That sounds good to me. Any other topics, or should we flip over to that?
Yeah, it would be nice to talk about this.
Okay. So that's this one right here, right?
Yeah, right.
Okay. Do you want to share? Or do you want me to?
Yeah, I can share.
Okay. Yeah, I think it's probably easier if you control. So I'll let you share and.
Can you see my screen?
I can.
Awesome. So I have summarized two problems with the finalization in the core that we have in the core previously that is not very clear about when to delete the reference or this kinds of problems. So when I'm refactoring, when I'm working on this part of code, I summarize that we have to distinguish two problems here before we can go through the code base to understand what's going on here. So the first one is the ownership. Previously currently we have several kinds of references or like say finalizers that have different ownerships. The first is the user-owned references. That is to say, users are responsible to delete these references with, like say, Node API delete references or NAPI Node API remove wrap. even if these references are weak references, the user are responsible to delete these references to avoid memory leaks. And the other kind of
Sorry, just on the nappy wrap, though, shouldn't once you you don't need to remove it. When the object gets deleted, it should delete the wrapped object, shouldn't it? Or maybe that's no. So sorry, maybe that's.
You can get the object and the wrap is not removed, but if you are going to remove the I can check this part, but I'm sure in the document you have to. It's documented that remove wrap is necessary to call, but I can check that part.
Okay, I have a reference of a separate reference. Okay, I'm just thinking that there is some expectation that for a wrap, when the object is deleted, when the JavaScript object is deleted, it's going to delete the corresponding C++ object. The wrap object.
The wrap is a little bit different from the reference non-pre-ref types, since they are it's a little bit different, but I can go through the other part of the document.
Sure. Okay.
The other kind of the reference is that these references are automatically deleted by the runtime, and when the finalizers are called, so user didn't get the handle of the nappy-ref or any other kind of types they can use to delete users can delete later, so it's automatically deleted by the runtime, and users finalizer just code, so they don't have to do anything with it. This includes the nappy instance data and the external type, and when the nappy wrap, when the in-out nappy wrap parameter is not set, and similar to the nappy edit finalizer, when the in-out nappy wrap parameter is not set. So this kind of references are automatically deleted by the runtime when the finalizers are called. So this is the ownership part of the references, and for the user-owned references, there are three kinds of timings that user can code delete. The first one is that user can delete it before the weak callback is invoked. Like say when the reference is a strong reference, and the user can delete it when since the weak callback is never going to be called, so user have to delete it before the weak callback, or when the reference is a weak reference and the delete is called before the weak callback. And the second one is that we have the V8 weak callback invoked, and we have scheduled the second pass callback to allow user to code into JavaScript. So there is a gap between the V8 weak callback and the user's finalizer are being called. So in this time, user can still delete the reference, and when the user call APIs like say get the reference value, then it will return a null pointer for users to fetch in the reference value. And the third one is that when the user's finalizers are called and the users user code deleting the reference in the finalizers or after the finalize doesn't matter. So to the runtime, the reference is just deleted after the finalizer is invoked. So
just one quick question so after the finalizer is invoked, is that the same as this when the second pass callback is invoked?
yes, this is a second pass call. Users finalizer are invoked in the second pass callback. So, and possibly in the environment shutdown. So it's but before the PR of this one,
Yeah,
these two are the second pass callback and the environment shutdown is two distinct phases that can collide with each other. So that's the problem we have before around the
I guess that's what I'm
around
trying to
the
understand. Is there is it number 3 is like delete is called after the finalizer is invoked in the second pass callback?
and it can either in the second pass callback or when the environment is shutting down. Since we are draining the immediately call the
Right.
finalizers, immediately call the checked finalizers when the environment is shutting down, so that users data point can be deleted when the environment is shutting down.
Right. Now that I just thought I'm thinking it's good to call out those two separate cases differently, maybe.
Yeah. And so since this is the core of the problem we have previously to, like, say, creating a second pass parameter, since the second pass callback is not cancelable. So that's the problem we have, let's say, creating a lot of intermediate structures to prevent double free or free after access after free.
Right.
So that's the point that we can, like, say, when we can generalize these two cases so that we can merge them into one. That is to say how we can make sure when the environment is shut down and the second pass callback is never being called. That is to cancel the second pass callback. Since V8 API didn't provide such mechanisms, since there is no cancellation handles or any other API is being exposed. So the simplest solution is that we can schedule our own second pass callback with set immediate, since set immediate is implemented in the core, and it's definitely to be invoked when the environment shut down. It's guaranteed to be invoked in the environment shutdown. So we don't have to add another layer of abstraction over this scheduling. Also, we can make sure when the Node API environment is destructing, we can drain the second pass callback queue, and we can make sure no second pass callback can be triggered after the node environment is being destructed. That is to say, no second pass callback can be triggered after the whole node add-on environment is destroyed, so that we don't have to we don't need to provide another layer of abstraction, like say second pass callback parameter we have before. So this can reduce the this can like say removes many concepts around the finalization. I can
So
point
maybe
to the
I'm just not completely following yet. So like that, in terms of like emptying the queue, like I think it was near the top, you
Here
had
is the-
like in the M, when the M goes away.
I'm sorry.
Like I think at the beginning you had like, it was like the M was going away or something. Like the destructor for the M.
Yeah, at the destruction of the M, we are changing the second pass callback queue, and so that all second pass callback are invoked before the M is before the M is totally destructed.
Right, can you just go back to that code again, just to?
Yeah.
So like that drain finalizer queue, was that an existing method we already called somewhere, or is that a new method that you've created?
It's called. There is only two code side of the drain finalizer queue. One is that in this set immediate code, which is when there is a finalizer second pass callback is scheduled. Like say in queue finalizer, will set immediate schedule set immediate when it is not scheduled, and unflag the and in the set immediate will drain the queue, or when the environment is shutting down will drain the queue.
Right, the existing one, the in queue finalizer, that's gonna, like, that is going to drain the queue for all references, right?
Not all references, since not all references are implementing the ref basic type, like say the RSA function. Currently, they have their own abstraction of finalizing,
Okay.
and but same applies to the buff finalizer. So we still have to call this one finalizer. So it
Okay.
will drain other kinds of finalizers that are not checked by the second pass callback.
Okay.
And particularly, this includes the instance data, if I remember correctly, since we don't have a V8 handle for the instance data, and so the instance data don't have a weak callback or second pass callback. It's just a finalizer, and it's just a checked finalizer, and it will be finalized in this function.
Right,
Think
can you
it's-
scroll down?
We
Sorry,
don't,
go
we don't
down.
need a second pass callback at all, right? Like because we don't do anything useful in second pass. Second pass only you can schedule set immediate today.
Sorry.
Second GC pass today does not actually calls finalizers. Today we just we call set immediate from second pass.
Yeah, that's another problem I documented here. It's unnecessary to reschedule the finalizer in the second pass callback, and so it's just unnecessary, I have to say. So
Yeah, we can just
with
schedule
this-
set immediate from first pass, and second pass we just simply need to eliminate. It's not
Yeah.
needed.
Since
I think
the
things were
whole
moved to the
point,
second pass callback though for a specific reason. Like in the first one, you can't run JavaScript or you can't.
Right, but if you look at the change history, we did exactly for that, but then we found that we can't capture JavaScript errors, and everything what second pass currently does, it's schedule set immediate. So just
second pass callback is scheduled by the node platform, which is scheduled with the UV loop, similar to the set immediate. So they are just I have to say this rescheduling with set immediate in the second pass callback is just unnecessary.
Right, okay, and I think if I understand what Vladimir said is we did that, but then that didn't let us do what we needed to do anyway, so then we added the set immediate. So if we just done the set immediate in the first place, that might have been the right answer. Is that okay?
yes, mhm.
Yeah,
And that's
I don't
exactly
know. I don't know why we wouldn't have done that in the first place.
I believe it's just it can be a mistake. I'm not sure. I have an impression that it can be unintentional. I can recall that maybe it's one of my PR that move the adding the set immediate in the second pass callback, but I can't say that it's totally unintentional.
But we need the set immediate. It's just that, yeah, we could have done it somewhere else. Is what you're saying?
Yeah, they are kind of similar to say, since the second pass callback is scheduled by node platform, and the node platform is scheduled with the UV loop.
Okay, so it does. I mean, I know we had quite a bit of stuff around that second pass callback, and like you said, I think you've done a fair amount of work to make sure that we could handle like had it been scheduled or not scheduled and all that. So
Yeah.
part of your change removes that, and we just do the set immediate in the first pass.
Yeah, right. We just set immediate schedule with set immediate in the week callback, and we can cancel the core problem is that once we can, like say, when previously the most issue is about this one, the second one, the second one and the third one, I have to say.
Yeah.
The second one, the problem with the second one is that we cannot cancel the second pass callback, so we have to create the second pass callback parameter.
Yep.
So that the parameter is deleted in the second pass callback, and the reference can be deleted early.
Yep.
And the third one is that it's about the double free. So since we can merge these two cases in, like say, we can merge these two cases in these two cases here, so we don't have any more about the double free.
Right. Okay. Because the env, I guess it's like the env is cleaned up as part of shutdown.
Yeah, and we can clear the second pass, schedule the second pass callback in the environment shutdown. So these two cases can be merged into one code path.
Right. So we won't set, like there won't be any second pass callback used at all in either case, right?
Yeah, right. I use the second pass callback term here just to reference that in this with the second pass callback, we can call it into JavaScript. But actually, in this PR, we no longer use the second pass callback anymore, the V8 second pass callback anymore.
Right.
And for the pointer 2, the delete is called before called after the weak callback and before the second pass callback. This is the case here. We can even the second pass callback is scheduled. We can still delete remove the schedule, and that is say dequeue the finalizer from the environment, so that it can no longer be its finalizer can no longer be invoked after it's been deleted. So this is a point to circumvent the pointer 2, since we can now cancel the scheduled callback.
So the DQ finalizer,
It's just removing it from the queue. It's fairly simple.
right? And those pending finalizers,
Yeah, it's a ordered set so that we can make sure each ref checker can only be queued once.
right? Pending finalizers. So pending finalizers is a method on the object itself, or that's an overall list.
And it's a list on the environment structure.
Right. Okay.
This is the
Should we have
NPM.
should we have like a special flag which because technically removing from this unordered set is still a non-trivial operation, and it seems like every time today we delete ref counter base, we always trying to kind of do this remove from unordered set. Should we have like a flag that we actually this ref base was added there in the first place?
Yeah, we can do that, but I'm not sure if it's needed since the operation is idempotent, but I can assume that this can introduce another performance issue, but that's an improvement we definitely can investigate if it's needed.
Okay. Another thing, what I talked about it before, but I don't really like us to call all these finalizers from destructor, especially our class is actually virtual class, and we may have potential lot of issues. What I would propose that we don't call from destructor anymore, but instead our environment has ref counter, right? So what we do, we typically call destructor, then this ref counter goes to 0. So I think it would be better if then ref count goes to 0, then at this point we call all our kind of finalizers and stuff, and our destructor does nothing effectively.
Yeah, I agree. When I'm experimenting around with this code path, I have encountered several times about the virtual finalizer issues, especially this finalizer O. It's actually their base class is also calling finalize O, because the finalize O is calling into the subclass methods, and so that we have to duplicate the code here to make sure in the base class destruct we no longer the finalize O is actually a non-op, to make sure the subclass method is not called in the base class destruct. So I believe I agree with your point that we should avoid calling this method in the destructors. But I believe, I think this can better fit in the follow-up PR, since this PR is kind of hard to review.
Yeah,
and
we don't
can
want
do it.
too much.
Yeah, I can do. I think I can definitely do it in a follow-up PR.
Sounds good.
So if you go to like the parse we finalized, so we in there was quite a bit of code that was checking things. Maybe it's worth looking. And
Yeah, this one.
yeah, so maybe if you scroll up a little bit, like there was the comments up the other one. Like that big block that's being deleted. Let's just take a look at this. So right.
Yeah, this part is especially about the environment shutdown, since this ref-based finalize can be called multiple times with the environment shutdown or with the second pass callback. That's the problem of the ref-based finalize here. So previously we added several mechanisms to the environment shutdown to circumvent the multiple invocation of this function. Let's say we set the ref count code to 0, and we mark this ref base as deleted to say it will flag this. It will set this flag to true. But actually, I think this is a bit confusing, since the delete self flag is actually used it's actually used to mark this ref base is runtime owned references, and it will be deleted after the, like you can see, if the delete self flag is true, it will delete this. So it's basically, it's basically yeah.
I guess like what I'm trying to understand is we had those cases were added. How do we, what's being done instead of those cases? So if you go back to that, like the first part that says, okay, scroll down just a little bit or up the other way. No, like, okay, so if basically we said if it's end tear down and the ref count is greater than 0, set the ref count to 0. Why don't we need to do that anymore?
Actually, if I remember correctly, previously when we added this part of code, we didn't actually resolve the problem, and we added a new patch about the and yet I have to revisit the history of this part, but I can recall that when we added this part of code, it actually didn't work out perfectly, and we counted a new case that can go down through here. It can be deleted twice. So the problem here is still about how do we prevent calling the finalize twice instead of adding new flags here. So when the ref-based finalize is called definitely once or 0, 1 at most once, this problem can be much more simpler here. First, we can just remove it from the checked finalizer list, and we call the finalizer. And if it's owned by the runtime, we just delete it. previously we, when the finalizer is not owned by the runtime, we'll set the flag here that the finalizer is run, and in the delete function, when we have either finalizer run or ref count is there, is ref count. When the reference is a strong reference, since when it's a strong reference, then there is no weak callback or second pass callback scheduled, so we can safely delete the reference. Or when the reference is owned by the runtime, so we can delete the reference, and no users will not delete it second time. So the other one is that when the reference is not owned by the runtime and we have the finalizer run, so the delete is called second time. That is to say, the delete, and right here. When we set the finalizer run flag, we actually didn't call this delete this, so that we can defer the delete to users' discretion. They can delete they can actually delete the reference when we have this flag finalizer run.
Right.
If the finalizer when the reference is owned by a user.
Right. So, but is there a new list then?
Sorry, what's new?
Is like, so okay, so I think I'm understanding what you're saying is like you've implemented a different way to make sure that it doesn't run twice, right?
Yeah, once the finalizer is run at the most once, the problem can be much simpler here, since we don't have to reuse most of the flags here, especially about the delete self flag, since at first place it's actually designed to mark the reference as a reference owned by the runtime. You can see it's a parameter in the constructor,
Right.
and we actually using it to mark the reference as a reference owned by the runtime, and the runtime is responsible to delete it. But after the iteration of this part of code, it's used to mark that the reference is used to mark the reference if the reference can be deleted. So this is two different use case of this flag. I find it can be confusing to understand how the delete self is working. So when we distinguish the ownership problem and the delete timing and the timing of the delete of reference, we can distinguish the usage of the flag, the delete self flag to say that this flag is only used to mark this reference as runtime owned.
Right.
So
okay.
the flag can be have much simpler meanings.
And later on, like, okay, so that if in terms of then in the new way of making sure it doesn't get run twice. So what's that? Like, how do we now say it's never going to be run twice? It's
yeah. So the ref-based finalize should only be previously it's called in a second pass callback, or when the finalize all is called.
right.
Since we have to delete all the checked ref finalizers. So this is two different code places, and the second pass callback can be invoked after the environment is being destructed. that you say we have already coded the finalize all here. So with the new mechanism, since we have changed all the finalizer queue and the finalizer, we also change the finalizer queue in the second pass callback, and so the environment cannot be that is to say after the destruction of the node M here, the queue will cannot be, the finalizer cannot be invoked.
So we now drain the queue every time we enqueue a new finalizer?
And no, we have a flag to indicate if we have scheduled a second pass callback, and we will do a batch drain in this set immediate callback.
So I guess I'm a little confused because I thought we weren't using second pass anymore at all.
Yeah, we didn't use V8 second pass callback anymore. We just use the term here. Maybe I can update the term here with a new term to indicate that a new phase that we can safely coding into JavaScript instead of reusing the term second pass callback.
Right. Okay. And so just I'll ask a few more questions, or I guess we got 2 minutes. One more question. I know one of the problems was when like the application goes to delete the reference. And I guess I'm trying to think of which case it was. It was like there was definitely cases where like either it would be deleted by the maybe it was by down the shutdown, but like there was it was, trying to double delete was a problem. Maybe that's that one right there. Yeah, okay.
Yeah, this is a double delete problem here. The finalize O, it's actually calling the ref basis, the ref base column finalize, and wait a minute. Yeah, the finalize O previously we just to call the ref base finalize, and in the ref base in the first phase, let's say when the environment is shutting down, it can actually didn't delete itself, since you can see it's just setting the flags, or in the delete this, it can still setting the flags and didn't delete the reference, or if the users,
yeah,
or if the users already here it's a little bit complicated, especially when, like, say we co-finalizer here didn't actually we do set a immediate in the co-finalizer, so the finalizer is actually didn't call here, it's deferred to a late point of the loop, and so at that point the second pass callback can come in, and it's so basically there is we can call the delete 3 times. The first one is the environment is shutting down, and the second one is that the second pass callback, and the third one is that we scheduled set immediate with the user's finalizer. So that's the problem here about the timings. So since with the new code, we the environment co-finalizer, it is immediately call the user's finalized callback. So user's finalized callback is not deferred to late point. So we cannot access, we have a comment here, we cannot access to this since it can be deleted if user have deleted. So this is analogous to the user's finalized function if the reference is owned by the node core.
Right. So, but the calling, okay, so you're saying call finalizer no longer defers, is no longer deferred?
Yeah, it's no longer deferred. So since we already calling the ref space finalize in the set with the set immediate, so it is saved calling into JavaScript here.
Okay, so you move the set immediate, like in there's more stuff pulled into what's deferred. Right, like the content of finalize itself is in a set immediate, right? Versus before it wasn't. Is that,
yeah, right.
Right. Okay. So that I can see being a significant, like basically all of that code is run in a place where we can run JavaScript. So it gets to run together with the other stuff. Okay.
Yeah.
I can see how that would significantly change things. Okay. Yeah. So when whoever calls like the finalize, okay, all the callers of finalize now do a set immediate.
Yeah, right.
Okay. Isn't that a public method?
No, all of this method is not public unless its behavior is being exposed with the C function.
Right.
The C function is just a simple delegation to the destruct. It's previously it's just deleting the it's delete let's see, delete reference. Yeah, previously we just calling the delete function, and since now we don't have such flags to set when deleting, we don't have such flags, so we can simply delete the reference and all the scheduled callback will be immediately canceled, and the reference will no longer be used anymore after the destruct.
So nappy delete reference is where we call the set immediate? No.
The delete reference can be called in these three cases.
Right. Okay.
So all of these three cases, we can simply cancel this callback if it's scheduled. So the reference can no longer be used. So the problem here can be much simpler since we don't have so many flags to set when deleting the reference.
Right. I was just wondering where is the set immediate added? Is that was the
it's actually here. Previously we have the call finalizer, and maybe I can. It's a red part of the code. You can see this is the set immediate in the call finalizer. So now the call finalizer is just a simple call back into module to protect the JavaScript exception.
And was call finalizer the only place that we could be calling where we couldn't run JavaScript? Like when the user calls delete on the, like, because the user can call delete, and that looks like it now just says, okay, I'm gonna destroy.
When the user calls delete explicitly, no callback will be triggered after that point. And the callback will be triggered by the delete. Since it's just a, sorry, the code is kind of long. So in the destruction of the reference, we just remove from the link and destruct this structure. And up to that point, this reference is definitely not used anymore.
Right, okay. So is that a difference, another significant difference, that the only way the finalizer is ever queued is when processing that list?
No, we actually, even before the delete is not, had nothing to do with the callbacks. You can see it's just setting the flags and prevent the callbacks, the later point callbacks to indicate, to help the later point callbacks to delete the reference if the flag is set. So it's just deferring the actual destructor of the reference.
Mhm.
Yeah.
Right. So if we delete the reference itself, I guess we're saying that, I'm just remembering, that means we will not run the finalizer.
Yeah, the finalizer is immediately canceled, and no callback will be called after this point.
Right, okay. So it's but it all the time, like the contract was always that if you delete the object itself, the finalizer isn't gonna run.
Yeah,
Right, it's up to you to do whatever cleanup, like if you've added a finalizer, I guess, or maybe it's just, we just added a finalizer to delete the object itself. I was just wondering, like, if it was like a case where like somebody said, hey, I want to run a finalizer when this reference is deleted. And we wanted to make sure that that ran whether you deleted it or it was no longer referenced. But I think the contract was if you delete the reference, then there's no finalizer that's going to run ever. So yeah.
yeah, right. But in any case, even without the change here, the contract here is that we only call users finalizer at most once. So
Right.
even though the ref-based finalizer is being called multiple times, users finalizer callback is called at most once.
Right. So now we call that during the delete. I think I'll have to, yeah, I'll look at the code some more, but I think this has helped with some of the keys, helped me understand a few of the key issues. Changes.
Yeah, that would be awesome.
We are past time. Anything else we should talk about this week before we close out?
Yeah, I don't have anything else.
Okay, if not, great. Thanks for everybody who took the time to join today, and we'll see everybody next time.
Yeah, see you.
Thank you.
Thanks.
See you next time.